Now the word binomial, its prefix bi means two in Latin. So bicycle has two wheels. Bilingual, being fluent in two languages. Binomial expression, having two terms in the expression. Now a binomial experiment is a probability experiment that satisfies the following conditions. So we have, there is a fixed number of independent trials n. Each trial has only two possible outcomes, success or failure, hence why it's named binomial. The probability of success p is the same in every trial. The probability of failure q is equal to 1 minus p. And the random variable x is the number of successes in n trials. Many probability experiments can be reduced to binomial experiments like this example here. So Humera forgot to study for her civics quiz. Now you can see there's 5 multiple choice questions. And for each of these questions there is 4 choices. And there's only one correct answer. Now, because the number of questions is fixed, we can see that n equals 5. And for each one of these questions, she's either correct or incorrect. So we can think of this as success or failure. So 2 outcomes. Now, in order to pass, she needs to answer at least 4 questions correctly. Now we'll look at this example in a little bit more detail in example 4. Example 1. Determine whether each experiment is a binomial experiment or can be reduced to a binomial experiment. If so, describe a trial, determine the random variable and state n, p and q. N is the number of trials, p is the probability of success and q is the probability of failure. Part A. The spinner at the right is spun 20 times to see how many times it lands on red. Now it can be reduced to a binomial experiment if success is landing on red and failure is any other outcome. So that's 2 outcomes, landing on red or any other outcome. Now the trial is a spin and the random variable x is equal to the number of reds spun. Now n equals 20 because there's 20 spins. The probability of success is equal to 1 out of 4. And you can see that here, 1 out of a possible 4 outcomes. The probability of failure is equal to 1 minus the probability of success, which is equal to 3 out of 4. Now, part B. 100 students are randomly asked their favourite food. This isn't a binomial experiment because there are many possible outcomes. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now, when conducting a binomial experiment, we want to follow 4 steps. So for step 1, we want to describe a trial for the situation and determine the number of trials to be conducted. Step 2, define a success and calculate the theoretical probabilities of success and failure. Step 3, describe the random variable x. And step 4, design and conduct a simulation to determine the experimental probability. Example 2. Conduct a binomial experiment to determine the probability of drawing an odd-numbered flashcard from a set of flashcards. So this consists of 52 cards, which is divided equally between 4 different colours, so you can see them here, and each colour is numbered from 1 to 13. And we want to then compare the experimental and theoretical probabilities of the experiment. Now, to conduct a binomial experiment, we'll start with step 1, which is to describe the trial, drawing flashcards from the set. N is equal to 52, which is the number of fixed trials. Step 2 will define what the success is. So, drawing an odd-numbered flashcard would be a success, and the probability of success we can now work out. So if you look at this pink set of cards, they're numbered from 1 to 13, and these are the odd numbers, and there's 7 in total. So for each of these colours, there's 7 odd-numbered cards. So we'll do 4 multiplied by 7 to give us 28 odd-numbered flashcards in the set. So to work out the probability of success, theoretically would be 28 out of 52, which I've written here. Now the probability of failure Q is equal to 1 minus the probability of success, which gives us 24 over 52. And then for step 3, we define the random variable x as being the number of odd-numbered flashcards drawn in 52 trials. The theoretical probability of success, P, is equal to 28 over 52. So now we want to work out the experimental probability to compare the two. So for step 4, we want to design and conduct a simulation. Now, one way you could complete the simulation is to actually use a set of flashcards. But for the purpose of this video, we'll use the random number generator on a calculator to create a simulation. So what we'll do is assign the integers 0 to 12 to accurately represent the probability data. So on your calculator, every time we see the numbers 0 to 6, we'll make a mark in a tally against the odd-numbered flashcard. Every time we see the numbers 7 to 12 on the calculator, we'll make a mark against the other flashcards in the tally, and we'll do this 52 times. So now I'll show you how to use this calculator to randomly generate the integers 0 to 12. So we press the alpha button, and then this button here, and this is what should turn up on your display. And we want to tell the calculator to randomly generate the numbers from 0 all the way up to 12. So we'll type in 0, 12, close brackets, and now your calculator is ready to use. Now that your calculator is set up, we just press equals to randomly generate a number. So we have 12 here, so this is where 12 is. So we'll put a mark against the other flashcards in our tally, like so. Press equals again, and we get a 7. So for 7, we put a mark against other flashcards in our tally, press equals again, and we get 3. So for 3, we put a mark against the odd-numbered flashcards in our tally. And we do this a total of 52 times. So once you've completed the 52 trials and you've marked them in the tally, you need to work out the frequencies. Now, this trial is for my specific experiment. When you do your experiment, these numbers will most likely differ. So we want to work out the experimental probability of success. So remember, success was an odd-numbered flashcard occurring, and there was 12 out of 52. So I can write that down here. And you can see if we compare this experimental probability to the theoretical probability, this is less than the theoretical probability. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now recall, in the binomial experiment we've just completed for example 2, there were 12 successes in 52 trials. However, if you conducted the same experiment again, there may be any number of successes from 0 to 52. So if you conducted the same experiment again, you may get 4 successes in 52 trials, or you may get 42 successes in 52 trials. This situation can be represented by a binomial distribution. A binomial distribution is a frequency distribution of the probability of each value of x, where the random variable x represents the number of successes in n trials. Now conveniently, the probabilities in a binomial distribution can be calculated using the following formula. So the probability of x, successes in n independent trials, is probability of x equals n choose x multiplied by p to the power of x multiplied by q to the power of n minus x. This is where n is the number of independent trials, x is the number of successes in n independent trials, P is the probability of success of an individual trial, and Q is the probability of failure on that same individual trial. Now remember, the random variable x is a discrete random variable, so the binomial distribution is a discrete probability distribution. Now you might notice by looking at this binomial probability formula, it's an adaptation of the binomial theorem. N choose x are the binomial coefficients. Now you've studied this before, but we'll look at the binomial theorem and how it's related to what we have here in greater detail in example 4. However, for example 3, we'll be using the binomial probability formula. Hamis is selling items from a catalogue to raise money for school. he has a 40% chance of making a sale each time he solicits a potential customer. So Hamis asks 10 people to purchase an item. Find the probability that 6 people make a purchase. Now we have these 4 choices here and one of them is the right answer. So let's define the random variable x as the number of times Hamis makes a sale. So making a sale is a success. Now the probability of success is equal to 0.4 because there's a 40% chance of making a sale. So we want the decimal form for the probability. So we'll divide the 40 by 100 to give us 0.4. The probability of failure is equal to 1 minus 0.4, which gives us 0.6. And the number of trials is equal to 10 because Hamis asks 10 people. This is our binomial probability formula. Now remember the question is asking, find the probability that 6 people make a purchase. So x is equal to 6. So we have x equals 6 and we have the values for p, q and n. We can substitute into this formula to give us the following and then use our calculator to give us the following answer. So this tells us the probability of Hamis making 6 sales is about 0.111 or 11.1%. So we can circle B as the correct answer. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. The mean of a binomial distribution can be calculated using the following. So what we have here represents the mean. Now this is a letter in the Greek alphabet and we pronounce this as mu. So the mean mu is equal to n, which is the number of trials, multiplied by p, which is the probability of success. Now recall from example 3, Hamis has a 40% chance of making a sale. Hamis asks 10 people to purchase an item. How many sales should Hamis expect to make? Now, what is the expected value is the same as asking what is the mean value. So we can calculate this by using the following. So we have n equals 10, we can see here. The probability of success is 0.4, which you can see here. We multiply the two together and we get 4. So we can now say that Hamis should expect to make 4 sales. Now the binomial probability formula only works out the probability for a specific outcome. If we want the full probability distribution, we can do this by fully expanding the binomial p plus q to the power of n. We know p is the probability of success, q is the probability of failure, and n is the number of trials. And we can expand this using the binomial theorem that you've studied before. Let's look at an example. Hamis has a 40% chance of making a sale. Hamis asks 4 people to purchase an item. Okay, we want the full probability distribution of this. So we want the values of p, q and n. So we can see n equals 4 because he asks 4 people. P equals 0.4 because there's a 40% chance of making a sale. And q, which is the probability of failure, is equal to 0.6. So we'll do 1 minus 0.4 to give us 0.6. Now, to work out the full probability distribution of this, we want to expand p plus q to the power of 4 using the binomial theorem. Now, it looks complicated, but with practice, you'll see that there is a pattern to it. So let's look at the binomial coefficients first. So n is 4. So it starts with 4. 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. And we stop there because they're the same numbers. If you look at the exponents for p, it starts with 4, n equals 4. And then it reduces by 1. So 4, 3, 2, 1, 0. And if you look at the exponents for q, it starts at 0, then it goes up by 1. So 0, 1, 2, 3, and 4. If we work out the binomial coefficients now using the calculator, we get the following. We can substitute for p and q using these values here to give us the following. And we can work out the probabilities as we have over here. And this is the full probability distribution. So the first one represents the probability of 4 sales, the probability of 3 sales, then 2 sales, then 1 sale, and then 0 sales. And you should notice that these probabilities should add up to 1. Example 4. Refer to the example in the beginning of the lesson. This is where Humaira sat a civics quiz and she forgot to study. So she randomly guessed the answers to these 5 multiple choice questions. Now we can reduce this to a binomial experiment. There's 5 fixed questions. so n equals 5. The probability of success, well, we know there's only one correct answer out of 4, so p is equal to 0.25, which is the same as 1 over 4. Now, q, which is the probability of failure, is equal to 0.75. And now we're ready to answer the rest of this question. Part A. Determine the probabilities associated with the number of questions Humaira answered correctly by calculating the probability distribution. So we want to expand this binomial, p plus q to the power of 5, because n equals 5. And when we use the binomial theorem, we can write the following. And remember, there's a pattern to this. Okay, the binomial coefficients using a calculator will give us the following. Okay, and then p and q we can substitute for using these values, which will give us the following, and then we can calculate the probabilities in decimal form. These should all add up to approximately 1. Now the first one represents the probability of 5 correct answers, then 4 correct answers, and then so on and so forth. Okay, and I've written the percentages here because they're easier to understand than the probabilities given in decimal form. Now remember, the probability distribution we can represent in table form, or even as a graph that I've drawn here. Part B. What is the probability that Humaira passes the quiz? Now remember, Humaira must answer at least 4 questions correctly to pass the quiz. That means she has to answer either 4 questions correctly or 5 questions correctly. So these two probabilities, all we then need to do is to add them up to give the probability in decimal form, and as a percentage we get 1.6%. Part C. How many questions should Humaira expect to answer correctly? Well, the expected value is the same as the mean value, which we can calculate using this, multiplying n by p. So n is 5, p is 0.25, and when we multiply them together, we get 1.25. Now, we'll round this answer to the nearest whole number. And we do that so that our answer to this question makes sense. So when we round this to the nearest whole number, we get 1. So on average, Humaira should expect to answer 1 question correctly when she guesses on 5. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now, just to summarise what we've learnt about the binomial distribution in this lesson, we have to remember there has to be a fixed number of independent trials n. So in this example, we have 5 fixed questions, or 5 independent trials, we can think of this as. Each trial or each question has only 2 possible outcomes, success or failure. So for each of these questions, the answer will either be correct or incorrect, so success or failure. The probability of success, p, is the same in every trial. So in this case, the probability of getting the correct answer is 1 out of 4, and it's the same for each one of these questions. And the probability of failure, q, is equal to 1 minus the probability of success. Now, the random variable x is the number of successes in n trials. So in this case, or in this example, a success would be getting a correct answer. So we could get 0 correct answers, or 1 correct answer, or 2, 3, 4, or 5 correct answers. Now, to find the probability for the number of successes in n trials, so the probability of x number of successes in n independent trials, we use the formula probability of x is equal to n choose x multiplied by p to the power of x multiplied by q to the power of n minus x, where n is the number of independent trials, x is the number of successes in n independent trials, p is the probability of success, and q is the probability of failure. Now finally, when we're asked to work out the expected value, we work out the mean mu, which is equal to n multiplied by p. So remember, this symbol here is a Greek letter and we pronounce it as mu, and this is the mean, n is the number of trials, and p is the probability of success.